How do you recover the very smallest gold? You know, in the old days, miners, with the stamp mills and stuff, they felt good about getting 75, 80, 80% of what was in the rock, and the other 15 to 20 and sometimes even more percent of the values just went right down the stream, that the mill dumped their tailings into. What a waste. And a lot of this was known, and at the time it was thought to be, as good as you're going to get. But the question is, how do you recover that really small gold? Because it's not the big gold that they're missing, it's the small stuff. And the truth is, every type of ore has some amount, sometimes a very large amount, of really, really small gold. Well, how do you recover it? You dissolve it. And if you're thinking, well, I can run a table or I can run a really good sluice box or something like that and recover the gold, it's like, well, just because you're recovering some 100 and 200 and 300 mesh gold in your system, that doesn't mean you're getting the majority of it. It doesn't mean you're getting even half of it. It doesn't mean you're only getting maybe 10 or 20% of that really small stuff, that dust. The way to recover that is by dissolving it. And in the 1890s, a guy came up with a method to do that with a chemical that was fairly common and fairly easy to get and comparatively inexpensive. Cyanide. Yep. He found that you could take a cyanide, soluble cyanide salts like a potassium cyanide or sodium cyanide, even calcium cyanide, something like that, and that with air it would dissolve the gold, and then you could recover it from the liquid. So how do you capture the smallest gold? You dissolve it. And this has become so popular, and there's so many. This is how big mining is done. It's how gold mining is done, for the last 125 years. It's done by dissolving the fine gold and then recovering it. And, we're going to talk today about cyanide. It's a super efficient method of getting gold. I'm not trying to give you a lesson on how to use it, but I'm going to tell you about it, and we'll go into the safety and some of the other aspects a little later on. But 70% of all the world's newly mined gold is recovered from cyanide. And the small scale miners and stuff like that that operate, placer miners, whether it's artisanal miners in developing nations or, places, in like the United States and Canada and Australia where, guys go out and look for gold for the fun of it, well, to make some money too, let's be honest. But, it's not like if I don't find a nugget, I'm going to starve. There's really a huge amount of gold that's recovered by cyanide, and you should know something about cyanide. Maybe someday you'll want to use it or look into it. So we're going to go into the issues of it. And first I want to take a look at the large-scale mining operations and how they work and what you get out of that, how the operation works. So let's take a look at that right now.
These are huge mines with giant equipment that process huge amounts of rock every day, and most of them mine 10,000, 20,000, even up to 50,000 tons of ore a day. It's a huge amount of rock and a very large operation. They employ large amounts of big equipment, scoops that may have 20 to 30 tons per scoop of the digging device, and trucks that may handle 50 to 250 or even more tons just in a single truckload. And the mines themselves are gigantic. They take up large parts of mountain ranges. And the whole key to this type of operation is that they handle huge amounts of rock very quickly and at very low cost. They move things and they sort and treat and do it at a low cost. Here's an example of some of this Carlin type gold ore from Nevada. Now, it doesn't look like much of anything, and honestly, if I was out hiking around and I saw a rock that looked like this, I wouldn't blink twice. But this rock has $175 to $200 a ton of gold in it. And, these mines, because of their huge size and the large amount of material that they handle, they're able to process rock like this for, something on the ballpark of about $25 US per ton. So when you figure you're talking $175 to $200 per ton, it costs you $25 a ton to get the gold out. You can see that these operations are hugely profitable. But they needed to have some sort of way to get the gold out, this microscopic gold, the way to get it out and get it out of the rock cheaply.
The process involves both what they call heap leaching and vat leaching. And vat leaching was what they did 125 years ago. But in the 1960s, they developed this process called heap leaching, and it's very simple. It's not as efficient as the vat leach, but it's still more efficient than the old ways that they used to do, like stamp mills and that kind of stuff. So let's take a look at heap leaching and vat leaching and really dive into the process, because heap leaching really is a simple way to get gold out of rock that's used by companies all around the world. And some, large scale, but there's even some smaller scale that's doing that. I did a smaller scale operation heap leaching here in Nevada with cyanide. So let's take a look at the heap leaching and vat leaching and kind of understand the process.
So this diagram shows that the heap underneath where it says geomembrane layer, that's basically a thick sheet of plastic that is impervious, so whatever liquids come down to that will drain off of it. You can see it's put on a small slope so that the liquid drains off into, here they have it green and labeled pregnant solution. But the lifts of ore are stacked up on each other, one on top of the next, and they'll build the first layer and then sprinkle cyanide on that, and then when they've got most of the gold and or silver out of it, they'll build the next lift and sprinkle cyanide on that, and build the next lift up and the next lift up, and so on and so forth. And that way they literally leach this type of thing for years, and it can grow to be several hundred feet high. It's basically a hill in and of itself. Now here's a picture of a large heap leach in Nevada. It's not the yellow flat area in the foreground, and it's not the darker hills in the background, but you can see the light colored area in the midground that looks like it's layers, one layer on top of another. They're as big as hills, but that's a heap leach where they've stacked up rock and they're leaching gold and silver out of the rock. Again, you see the light colored area out in the midground. This is a huge area that they've laid plastic underneath, and they're going to sprinkle cyanide on top of it. This is another giant heap leach.
Here's another diagram showing basically how the fluid is recycled through the solution. Here's another diagram showing how the fluid that is in the heap leach is recycled through the process. Now, the barren cyanide solution is mixed up originally, and it has the right, it's a low concentration of cyanide with the right somewhat basic pH is sprinkled onto the heap. And generally the process of putting it on the heap these days is the same kind of drip irrigation system that you would use to raise tomatoes in a hothouse, that kind of thing. I use in my garden to water my squash and stuff. It's just a drip feed type of thing, and it purchase it from agricultural type uses. Well, it's put on the pad, it soaks through. There's air, of course, in the space between the particles. One of the things about this is, and we'll talk about it in a second, is crushing it. It's usually not crushed to a super fine size, but the material percolates down. It's collected in the trough where it goes to the cyanide bearing collection area, marked in yellow on this diagram, and then is put into the gold extraction circuit where the gold is removed, and then they add any cyanide and other base material to bring it up to the right consistency for the barren cyanide solution, and it goes back up and then gets put back on the pad. And it's cycled through, and after going through the extraction circuit, additional water, additional cyanide, additional base cover material is added to bring it up to the proper strength, and then it is cycled back through. And so the water just gets reused, and all that's really lost as far as the water is evaporation. Here's a crushing plant made for heap leaching operations. It has various conveyors, and it's sized and screened and gotten to a certain size. When I ran my small heap leach in central Nevada, we crushed down to about -3/8 of an inch. And generally, it's not any smaller than that for heap leaching. Half inch or even inch is pretty common, -inch. And sometimes mines put on what they call run of mine, and it's just the breakage of the rock that's caused in the explosive that loosens it. And there's no extra crushing done other than the explosive. The heap leach is done with coarser rock. It's not crushed fine to sand as it is in the vat leaching process. In the vat leaching process, the material is crushed much smaller, which leads to a much higher level of recovery. Now, there's an additional cost to crushing the rock this small, but with more gold in the ore, it's worthwhile to crush to a finer size of material in order to get that higher recovery. Equipment like ball mills and rod mills are used to take these things, rotate and have crushing material inside them, and they take the rock down to that fine sand size. The fine sand is processed in large vats, and air is introduced at the bottom of the vat, and it bubbles through and keeps the sand and cyanide mixture stirred around so that there's plenty of oxygen for the reaction between the cyanide and the gold to dissolve it. The processing vats can either be indoors or outdoors, as in this example, and it's always that the low-grade ores are treated by something like heap leach, and the higher-grade ores are ground smaller and treated in a vat like this. The vat leach gets a much higher rate of recovery, but it's also a lot higher cost. The thing is, though, that with the higher grade ores, the additional gold that's in the ore makes it worthwhile for the additional cost of crushing and vat leaching.
Now let's talk a little bit about the basic chemistry of cyanide recovery. I'm not going to go into a deep chemistry lesson. That's not the level of this video. This is introductory and explanatory and learn a little bit about kind of video. It's not a how to be a chemist, that kind of thing. So the chemistry of it is basically, like I said, some sort of cyanide, water-soluble cyanide salt. This would be like sodium cyanide, potassium cyanide, calcium cyanide. These are all the most common cyanides. In fact, much less common potassium because it's a little bit more expensive, but sodium and calcium cyanide are the most common cyanide salts that are used in industry. And so I mark that here with CN minus. So it's CN and something else like CN and sodium or CN and calcium. Okay, so that CN is the chemical symbol for cyanide. And then AU, gold, plus O2, which is oxygen, and it's oxygen from the air, and plus water, and you get water-soluble sodium cyanide and the hydroxide ions. So this is not a balanced equation. I'm not trying to teach a chemistry class, so don't say, hey Chris, you didn't balance your equation. Yeah, this is not a chemistry class. This is a concept class. And so you need you need the cyanide, you need the gold, you need oxygen. And they prove this, that you can take cyanide in water that has no oxygen in it and put it in a container with no oxygen and put gold in there, and the cyanide won't dissolve. It needs the oxygen to go from being a metal to being a dissolved salt. So, when they do the vat leaching and do the heap leaching, both of them incorporate oxygen from the air. And then water, of course, you need, and then you get this soluble cyanide salt. And That's an important thing. Let's take a look at the different processes of, once you get the gold into solution, well, then you have to get it out, right? So let's look at the different processes for extracting the gold out of the solution. We've learned how to put it into solution with cyanide, and the cyanide solutions that are used are very dilute. I once calculated that the concentration that we were using at the mine where I did a cyanide leach, a heap leach type of process, that the lethal dose was somewhere around a cup of the liquid. So, it's dilute enough that to get a little bit, you'd have to drink a whole cup. And not that I would drink it and test it to see, because some people are more sensitive than others, but it's not something where if one drop lands on your tongue, you're dead. It's not that concentrated. So they use these dilute solutions, and then you have to get the gold out. So let's talk about how they get the gold out of the solution, the different methods. It's Merrill-Crowe and the carbon and that sort of thing. Let's talk about that and go over that right now.
For ores that have very little silver and are mostly gold and not significant silver, carbon is used, and it's an activated carbon. This carbon is made from coconut shells, and it's used very commonly in many types of cyanide because the gold cyanide in the liquid will absorb or adsorb right onto the surface of the carbon and load it up, and it'll come out of the solution and collect on the surface of the carbon. These types of systems are really very easy to construct. They're cylinders with a screening area on the bottom and top of the cage in the cylinder, and the carbon is put in there and sealed in, and then fluid flows up through the activated carbon and out. And they're usually arranged with multiples of these cylinders, so they can be using some of them to take the gold out of solution and others of them to strip the gold off the carbon, because the carbon will only absorb so much, and then there's a process to remove it. And there's different ones that involve various processes, but the gold can be removed from the carbon after a certain amount of time. The other common type of system is what's called Merrill-Crowe, and it uses powdered zinc to capture the gold and silver. This type of system is used where you have significant silver with your cyanide, and whether you've got half or even more than half silver by weight. And the process that we were using at the heap leach that I ran was significant silver. In fact, we had way more silver by weight than gold, and so this is what we used. The white unit both of the white units are basically filter presses that are used for pool filters, and the one on the left is used to clarify the solution, to capture any mud or clay. And then the tall tower is a deaeration tower. When you use zinc, you have to take air out of the cyanide pregnant solution. You have to deaerate it, and then it's pumped into the pool filter on the right, and that has the powdered zinc in it, and the cyanide reacts with the powdered zinc, and you end up with the zinc going into solution, and the silver, the gold and silver come out of solution into the pool filter, and the zinc goes into solution, replacing the gold and silver. And whichever process you use, the material that you recover is dried and mixed with fluxes and melted and poured into a bar or button form. And you end up with an impure bar or button that needs to go to a refiner to be purified. Of course, at the one that I worked at, we had way more silver than gold, so our buttons would be silver in appearance. This is not the mine I operated, but this is me at a different silver gold mine with over 1,000 pounds of silver. And even though the doré here is 98%, something like that, silver, it still is a couple percent gold. And when you have more than 1,000 pounds, we're talking 20 pounds of gold here too.
Okay, we've talked about recovery methods and how you get the liquefied gold out of the solution and back to be a metal. Now let's talk about ores that work and ores that don't. Because the truth is, not every ore works great with cyanide. Some ores have problems. Some ores require special treatment. Some ores work great, just all you gotta do is crush it and get it going. So let's talk about what you do with the ores and how they process them. We'll talk a little bit about crushing and that sort of thing, and we'll go into the details of how you find out if your ore is a good ore to work with cyanide or not. Because basically what works with cyanide is ores that are oxidized and don't have huge amounts of sulfide in them. If they have sulfides, they do require special treatment. So let's talk about it further.
The best kind of ore for cyanide is stuff like this, stuff that's highly oxidized. Now, this once had some pyrite in it, but the effect of oxygen from the air and water from rain and snow have just basically converted whatever pyrite was in this rock into rust. And so you see stains that look like rust stains. Well, they are, because this is a well-oxidized piece of gold and silver ore. Here's another piece of well-oxidized ore. This is from the Carlin mine on the Carlin Trend in Nevada. And the gold here is really, it requires a microscope to see it. But the ore is well oxidized and easy to leach, crush, and it works fine for cyanide. So let's talk about types of gold ore that don't work well with cyanide. And here's a piece of lovely quartz with very coarse, big chunks of gold through it. This doesn't work with cyanide. Now, cyanide will dissolve gold, coarse or small, but the problem is it's not super fast. And so the cyanide process like on this, whereas it might take hours on the ore I just showed you, it would take years, maybe even decades to process and dissolve the gold on really coarse gold like this. So when a mine has ores with coarse gold like this, they'll have a gravity circuit, something with a table or a centrifuge or something else to capture the coarse gold. But then once all the coarse gold is removed, then the fine gold that's still left in the ore, the tiny particles, can be treated by cyanide. Another type of ore that doesn't work well is ore rich in sulfides. In general speaking, the sulfides will encapsulate or enclose the gold and silver values, if there's any silver values. It encloses it, and so the cyanide fluid can't get to it because it's like locked up in the sulfides. And so when you have an ore with rich sulfides in it, it has to be treated first, and sometimes they do roasting and sometimes they do oxidation in something like an autoclave. But one way or another, the sulfides have to be oxidized before the cyanide can get into the particles and do their job of dissolving them. Another type of ore that doesn't work with cyanide is types of ore with lots of oxidized copper in them, like this piece, where the blue is oxidized copper mineral chrysocolla. But other oxidized copper minerals are just as much a problem. And the problem is that the cyanide reacts with the copper, and of course there's always loads more copper than there is gold or silver. And basically the copper consumes the cyanide and it's not available to react with the gold and silver. So I hope you get the feeling that not every ore works well with cyanide, or even if it can be made, it requires special treatment to get it to work. So cyanide is a great thing and produces, like I say, 70% of the world's newly mined gold, but it's not for every type of ore.
Okay, so let's talk about cyanide dangers. Everybody knows, and if you don't, let me tell you, cyanide is a terrible, fast-acting poison. And how it kills you is, in your blood, there are molecules of combined iron. It's not metallic iron, it's iron chemicals. There's the chemical in your blood called hemoglobin has some iron atoms in it. It's not metallic, but it's combined with the other things in the atom. And it's that iron molecule that carries the oxygen from your lungs to other parts of your body, your brain or muscles or whatever, and carries it there. And gets that oxygen from your lungs to where it needs to go. And when your blood has oxygen in it and it's oxygenated, it's red. But when it's depleted of oxygen, it's blue. And you can actually see that in some of your veins. Some of your veins will look bluish. It's veins that are returning, having depleted their oxygen. But what cyanide does is cyanide gloms onto that iron and won't let it carry oxygen. The iron wants to carry the cyanide more than it carries the oxygen. And so when you get cyanide into your system, it contacts the iron in your blood and makes it so that your blood can't carry oxygen. And so you basically die of suffocation. You die of lack of oxygen because your blood can no longer carry oxygen. And, it doesn't take a lot. Somewhere around a half a gram, which is not very much, is the lethal dose for about half the population. So it doesn't take a lot of cyanide. And in fact, when we used to handle it, with breath protection, because there's a chance that you could breathe a little dust, and you could breathe enough dust if you were in a dusty environment with dust from the cyanide. So let's take an actual look at some cyanide. When we used to get cyanide delivered to us, and hey, when I ran that heap leach, I actually went and bought cyanide and brought it to the mine, and it was small scale, so it wasn't like a chemical company delivered 4 truckloads of cyanide. I went out to a chemical place and got a drum of cyanide, and they loaded it into my pickup truck, and we took it back out to the mine. Restrictions are much more serious now than they were back in the early 80s. So anyway, when the cyanide, let me show you what cyanide looks like, both in the briquette form, which is the bigger low dust form that we had, and other forms that could be higher in dust. So, the toxicity of cyanide is a big deal, and it doesn't take a lot. And let me show you what we have.
And you can see it's simply just a white or colorless salt. I've seen coarse sugar that looks like this, so you just can't tell by looking at things.
This is what you'd get if you bought just a bottle of reagent chemical cyanide from a chemical supply company. But in the mining industry, this is too dusty stuff, so we use a different form, the briquettes.
And you can see here, like I said, it looks exactly like charcoal briquettes that you'd use in your barbecue, except instead of being black, they're white.
So again, I'm going to say this is not a how-to video. Another danger of cyanide that I want to be sure to notice to you is the acidity basic level, pH, what chemists call it. And cyanide, if you put it in an acidic solution, or you let the solution that has cyanide in it become acidic, and that's possible with contact with sulfides. Sulfides can get oxygen from the air and react and produce acidic solutions. That's what acid mine drainage is. It's iron that's gotten acidic, and so. But if you let cyanide get acidic, it will generate a gas. It's called cyanogen gas, and it's the gas they use in the gas chamber to kill people. So the chemical is dangerous, but so is the gas that comes from it. So when they use cyanide in the mines, they always keep control of the pH and keep it nice and basic. If you make it excessively basic, it doesn't work as well, so it won't dissolve the gold as well. But they keep it moderately basic so that it won't evolve and turn into this gas, and so it'll stay as cyanide in solution. And so it's important to understand the pH, to measure the pH and control the pH and keep it moderately basic. That's one of the dangers of cyanide. And the mines do this too, because even if it off gases just a little bit and doesn't hurt anybody but goes into the air and goes downstream, they're losing cyanide, so they don't want to have to pay for it to go off into the air. They want to keep it in their solution where they can dissolve gold with it, where nobody's going to get hurt if you don't drink it. So that's a deal. And then another thing that goes with the cyanide, in the old days when we had ponds for this, we just had these open ponds that, the cyanide would go onto the heap, it would drain off the heap. We had a settling pond that had the pregnant solution in it, and then a final pond that we pumped out of to recover the gold, because we used Merrill-Crowe with zinc. We recovered the gold out of the pond, and then there was a head pond that after it was processed and the gold extracted, we went up to this head pond, and then the upper pond, it was sprinkled onto the heap and then went through the whole cycle. But the open ponds, both whether it's a pregnant solution that has gold in it or the barren solution that doesn't have gold in it, either way, it's potentially poisonous to any animal life that gets in there. We had fences around it, so there wasn't like a cow or a deer or something was going to wander in there. But there were birds that would land, and if the birds drink it, it doesn't take very much. Birds are real sensitive. So there's a danger to wildlife that you need to be aware of. And finally, let's talk about cyanide alternatives, right? So we've gone over the cyanide, and it's like, oh, it's kind of dangerous, I'm kind of hesitant to use it. And if you don't understand the chemistry of it, if you're not in full comprehension of all the chemistry and potential reactions that could go on with your ore, you don't want to use cyanide until you can, until you understand that. So, you have to have a level of chemistry expertise. And I can't be your chemist. I'm retired. I've got a lot of family obligations and stuff. So, if you want to think about contacting me, well, Chris, you can help me get started with cyanide. It's like, no, I can't. I just don't have the time available. And I wish you the luck. You can study and learn for yourself. But cyanide alternatives, there are some alternatives. Now, the problem is there's not a lot of them, and all the alternatives have their own downside. Chlorine is, it was actually used in recovering gold before they developed the cyanide process. So in the 1880s and early 1890s, because it was discovered around 1890, the process was developed for cyanide. But before that, there were some plants that used chlorine on ore to dissolve, because chlorine gas dissolved in water will react with the gold particles, even the small ones, and then that will produce a gold chloride that's in solution, right? And then you have to go through and extract the gold chloride from your solution, but it still is dissolved. Well, the problem is chlorine gas isn't exactly good for you either. It may not be quite as deadly as, but it doesn't take much chlorine to make you sick or to kill you. And in fact, in World War I, they used chlorine gas as a weapon, a chemical war agent, and it was outlawed by the Geneva Convention. Don't use that stuff, it's bad. So, yeah, chlorine certainly has its drawbacks. Thiosulfate, though, is one that has potential. And to this day, there's more and more research that's ongoing about using thiosulfate, and you can look forward to a video that I'm going to be coming out with shortly on using thiosulfate to recover some silver ore. Now, thiosulfate works really good on silver, actually better than cyanide on silver. It works a little bit less efficient on gold than cyanide, but thiosulfate is way less toxic. Obviously, if you sat down and ate a pound of thiosulfate, you would be dead. But the truth is, if you took a pound of regular sodium chloride table salt, rock salt, like a whole big thing of Morton salt, and just ate it, the table salt would kill you too. So actually thiosulfate, small amounts are used as a medication, and small amounts of thiosulfate is actually the antidote to cyanide. So that if you get a cyanide poisoning it's not enough to kill you right away, you could, if there's thiosulfate there, you can take the thiosulfate and it will counteract the cyanide. It will basically react with the cyanide and eliminate it so it won't glom onto the iron in your hemoglobin. So thiosulfate, much less toxic, it does work. The problem with thiosulfate is that it's not nearly as stable as cyanide. And so you get it into solution, you have to really closely control the pH, just like you do with cyanide, and closely control various factors, because otherwise it'll decompose. And it doesn't decompose to make some super nasty toxic, but once it decomposes, it's not going to capture your gold or your silver. But anyway, I'm going to do a video, and it's coming up. I've already started it, but it's going to take a while to go through the whole process, to recover silver from some silver ore that I have that's high in silver. It's really low in gold. It doesn't have enough gold to really hardly worry about, but it does have some pretty good silver in it. And so we're going to use thiosulfate. I'm going to do a demonstration with that, and we'll talk definitely more about thiosulfate chemistry in that video. So now you know a little bit more about cyanide and some cyanide alternatives. But in all of your prospecting, the more you know is the better chances you're going to have of success, of finding good ore, or understanding the geology and how to find gold, find silver. I wrote a book called Fistful of Gold to impart to you my 4 decades of experience plus my degree in mining engineering, to give you a start in being more successful in your prospecting. And I'm also partnered with an outfit called High Plains Prospectors. That's a prospecting equipment shop. And I'm going to tell you a little bit more about High Plains and my book right now. This is my book, Fistful of Gold. It's an encyclopedia of everything you need to know to go out and find gold for yourself. It distills down my 45 years of experience out in the field prospecting, as well as my degree in mine engineering. It's, like I say, an encyclopedia. There's a lot to it. It's over 250,000 words long, hundreds of pages with hundreds of illustrations, teaching you what you need to know about geology, about mining districts, about techniques of finding gold. It covers metal detectors, sluicing, panning, dry washing, high bankers, you name it, it's covered in there. It talks some about platinum and diamonds, but it's mostly about gold because gold is more widespread. It is not so much a book about where to find gold, but a book about how to find gold. Because even if you have a location where gold was mined in the past and you go out there, well, where should you look to be successful in your prospecting, to find the gold that's there? This is the book that's going to tell you that information. I spent most of 10 years writing this book, so I thought a long time about it. It's got, like I say, lots of information and lots of illustrations, and I've had results from people who bought it. It's available on Amazon, but I recommend buying it through High Plains Prospectors, and I'll put a link in the description for buying this book through them. They have a better price than Amazon, and I have a special deal that I'll tell you a little bit more about, where you can get a 5% discount from the price even with that. On Amazon, the book rates a 4.7 out of 5, which means that of all the people that have bought it, they've been really highly satisfied, and I think you, if you buy my book, will be just as highly satisfied as well. Now let's talk a little bit more about High Plains Prospectors. They're a prospecting shop, a mail order prospecting shop that I've partnered with. The deal is that I can get you a 5% discount, a coupon code, and I'm going to put the code to that right here. It's just Chris Ralph, all caps with no space between Chris and Ralph. You put that in there as a discount code and you'll get 5% off their already really good prices. I think it's a great deal where you win by getting a discount, I get a little percentage of that, and they get new business. So if you need prospecting supplies, High Plains is really the way to go. And I'll put information, like I say, in the description more about how you can work with them, because I'm working with them. They really are great guys, a great company. For even more information, I also have a website, and I'm going to show you my webpage and talk a little bit more about that right now.
This is my webpage. It's located at nevadaoutbackgems.com. You can Google it, or I have a link down in the description below. But there's lots of information here, miscellaneous stuff, pictures, some historic information as well, stories. It's got a lot of great fun stuff. You'll probably be interested in it.
Now, on all of my YouTube videos, I encourage you guys to ask questions. If you have thoughts, comments, suggestions for things that I ought to look at in my videos, things that you want to find out more about, and I answer 100% of my questions. There's not very many YouTubers out there that answer 100% of their questions. I'm one of the few. And so I will do my best to answer what you have. I mean, I only can write so much. Sometimes the answer is something where I'm going to recommend that you buy the book and read about it. I also ask that you subscribe to my channel, click the bell notification so that every time I come out with a new video, you'll be able to watch it. And like I say, I cover a huge amount of topics. I also have 250 videos that I've already done. And so you can go back through my catalog of videos on YouTube. I'm sure there'll be many videos there that you'll want to take a look at, especially if you have any interest in gold or platinum, diamonds, gemstones, geology, and that sort of stuff. My YouTube site is going to be right up your alley. So I'll see you again real soon. We'll be out in the field and back in the office at the whiteboard, and whether we're looking at gold or platinum, diamonds, gemstones, or other interesting geology, it's going to be fun. You're going to enjoy it, and we'll see you again real soon.